And I don't have the numbers right in front of me, but I came up with something like 90 megatons worth of weapons on one Ohio class submarine in the 70s.
Yeah.
Maybe I'm a little off, but like it's basically a Zarbamba submarine, right? And I like to bring this up because we like to make fun of the Zarbamba, like, oh my God, so ridiculous, so many megatons, so pointless. And like, yeah, sure, it is in many ways. And the US flirted with making its own weapons that big too at the same time, because I don't know, there's something to that maybe. And even the Edward Teller stuff, the gigaton range stuff. Oh my God, so ridiculous, a doomsday machine. But like, we still built things like this. We just broke it into a lot of different pieces. And Dan Ellsberg, the late Dan Ellsberg, he made this argument, which I think is right, which is like, we still built a doomsday machine. We just didn't do it in one machine. We did it in a system. And it would still be, this horrible thing. And I think that's a valid way to think about it.
Welcome back to Decouple. And welcome back, Professor Alex Wellerstein.
I'm happy to be here. It's good to talk again.
So we are recording our episode 2 here. As we were mentioning in the first episode, it was high time after 240 episodes to chat about the bomb. So we had we have to talk about the bomb, and it was a part 1. Really fun show. Again, I'm the son of 2 academics, and I was very impressed with how much ground we were able to cover, despite you having some real areas of expertise that we didn't dive into. But we covered really the origin story, the Manhattan Project, which obviously had relevance to the development of atomic energy for peaceful purposes as well. But just really went through that crash program, that 2-year program, which resulted in the creation of the bomb. And we probably got up to the decision, and we definitely got up to the decision. Very interesting about dropping the bomb on Japan, and a little bit about U.S. atomic hegemony post-war. So, very characteristically over ambitiously, I'm hoping to just breeze through that post-World War II history and bring us right up to the present, which is completely unrealistic. But I guess some highlights I wanted to touch on were I guess like the conflicts in which nuclear weapons were seriously on the table. I'm guessing that's Korea and Cuba, the Cuban Missile Crisis. The scaling up of nuclear weapons, both in their sheer destructiveness, but also numbers, and just kind of how crazy that got. Some close calls, and I'm super interested in the evolution of command and control, the nuclear football. Whether there's sort of best practices that have emerged that are kind of shared between all the weapons countries, I have no idea, but I'm really interested about that. So those will be the focuses, and I'm sure we'll have many tangents along the way. But again, great to have you back. Really enjoyed that first episode.
Oh, I'm happy to be here. This is my bread and butter. It's fun.
Beautiful. And I failed to mention in the intro again, you're a professor of science at the Stevens Institute of Technology, author of Restricted Data, The History of Nuclear Secrecy in the United States. And you have a forthcoming book on Truman, which features Korea prominently, I'm guessing. So maybe we should start there in terms of, again, touching on a few of the conflicts where we got close.
I'm going to make one more plug for I just started a thing which people can go to, doomsdaymachines.net. It's a new online thing about how people think about the end of the world. So it'll be really fun. So Doomsday Machines, plural.net.
Okay, and that's live right now.
It's there right now. There's a page that says it's coming soon. It'll be live in July. So whenever this goes up, maybe it's live by then.
Okay. Beautiful. All right. So yeah, let's talk about let's do it.
Yeah, I mean, Korea is, to me, it's what. So in my book, which is about Truman and the bomb, which covers his whole administration, it's not just Hiroshima and Nagasaki. Korea is not sort of even the end of it. It's almost like the climax of it in a way, because maybe there's 2 climaxes. Maybe they use the bomb and that's a climax, and Korea is another. But it's a fascinating thing because this is a time in which the U.S. could have used nuclear weapons in a variety of ways in the war. And a lot of people expected that it would, that this is exactly the kind of situation in which you might do that. And it presents this interesting question, like, why didn't we? And the sort of glib answer you get is, the Soviet Union had nuclear weapons. The Soviet Union had like 1 nuclear weapon. It was not a mutually assured destruction situation. Even if they had a few more, they did not have the realistic ability to project that power onto the United States. The United States had hundreds of nuclear weapons at this point. Like it's not and I guess this is just we get to this we talk about stockpiles. It's not balanced in any way. Like the U.S. the arms nuclear arms race is not at parity in terms of being like equal capability until maybe the late 70s, early 80s.
Wow.
So there's this whole period in which yes, the Soviets have weapons, but we have like we'll jump just to jump to Cuban Missile Crisis, we had like 20-1 advantage in nuclear weapons at the Cuban Missile Crisis. It's not even close. And whether that matters or not is, of course, a big discussion point. But for 1950, 1951, that isn't the reason. It's not that the fear was Soviet retaliation. That nobody voices that within the government when talking about this as a reason not to do it. They have a lot of reasons that they don't that they end up not doing it, or reasons against doing it, but that isn't one of them.
And this is occurring within the kind of stalemate of the North having invaded the South, and then I guess this joint task force having pushed them out and kind of into the North, and China getting involved, and then the kind of stalemate afterwards. Is that kind of when nuclear weapons come into the conversation? And is this General MacArthur pushing for their use?
So what's interesting is like the actual tensions, they're not usually stalemate. It's not like the nukes will break the stalemate. It's periods in which there's this fear that like that there could be this increased push by the other side, right? So it's actually usually not the stalemate portions, it's the portions in which the US is not doing that well. That's when people start saying, hey, maybe nukes are what we use to offset this thing.
Right.
Um, and MacArthur is part of this. It's interesting because MacArthur, it's complicated because there's the sort of what MacArthur did, and then there's the what MacArthur later said he did, and these are not exactly the same thing, though they have interesting overlaps. So, like MacArthur during the Korean War is so, for example, in late 1950, Truman gives this press conference with reporters, and he gets asked, "Are nuclear weapons on the table?" And he sort of, it's an offhand comment. He says, everything's on the table. It's always on the table. Of course, the bomb's on the table. There's nothing that's not on the table. And this gets taken as a big statement of like, oh my God, US is considering using nukes in Korea. It's a thing, which it wasn't. And we can get to this, but Truman, I don't think had any intention of using nuclear weapons in Korea. And ultimately that's why they're not used. Whatever the other reasons are, he he just wasn't interested in doing it. It was not something he ever thought was going to be a good idea. Um, and that's what the book is trying to probe into. Okay, how do we get there? How do you get from nukes are great on Japan, but like totally unthinkable afterwards? To me, that's the conundrum of Truman and the bomb.
Right. Right.
But this press conference gets all this attention, and it even gets attention from MacArthur because he's seeing the dispatches on this. And so one of his people says, oh, let's imagine they did want to give us nukes to use. How would you want to use them? And MacArthur like instantly rattles off all these targets he would hit. Like he's got like, I forget, it's like 15 ready to go. And they're mostly in China, which is interesting. They're like airfields and military bases in China. He's like, yeah, I'd hit all these targets. It'd be great. And then it comes back, you're not getting nukes. I'm just this was a whole confusion thing. But I thought it was interesting that he did this. And this we know he did because we have the correspondence, the sending him back to his bosses, but we also have like the diary of the guy who was his number two who wrote all this down, which is super handy. I wish everybody had an assistant who did that. Historically. After the war, MacArthur had he was, just for people who are not aware of all the ins and outs of this, Truman eventually fires MacArthur. And it's a big political, hairy deal because MacArthur is relatively popular publicly, and Truman is not at this time. And MacArthur is this gets sort of mobilized by anti-Truman forces, and MacArthur is also this kind of bellicose bully of a personality. He's a real pain in the neck. And so he goes on this essential campaign to voice his unhappiness. And he has lots of people who want to back him up on this because they see it as this anti Truman thing. I think in the long run, people have concluded that MacArthur was not a good guy or a good general, even. But like at the time, that wasn't as clear in all quarters. And so he tells people stuff, some of which only comes out way later, like decades later about what he would have done if it was up to him, and it's just insanity. It's like, oh, I would have like created a belt of radioactivity across the border, and then we'd use radioactive warfare, and then I'd nuke all these bases, and then I'd bring in the Taiwanese forces, and they have like a bunch of people, and then we would just have taken over everything, and China wouldn't have got involved because they won't even mess with us. And you're just like, wow, that's unhinged. And I'm
Right.
not sure. It's hard for me to tell how much of that is actually something he would have advocated while he was in charge versus what he advocates when he's doing Monday morning quarterbacking. And I don't know. Uh, but 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 yeah, he's bellicose and he's more pro nuke certainly than Truman was, and that is, I think, part of. It's not the exact reason why MacArthur gets fired, because that's a very specific thing. That's him basically contradicting the president in public statements, and you just don't do that. And he gets told he's not supposed to do that, and he does it again, and so that's it. It's like insubordination. But that's part of it. Is like the idea that he's kind of unhinged.
Well, and that touches on one of the, I guess, the themes we were talking about last time, which is the tension between the military and the civilian control of nuclear weapons. I mean, the U.S. military is, I mean, I guess it's kind of been bloated ever since, but after World War II, there's been significant investment. I guess in World War One, they moved from an isolationist position to a mobilized position. But yeah, I mean, a massive military industrial complex. How does control of nuclear weapons end up on the civilian side? It seems like that happened pretty early on. But I guess if the
Yeah.
military had more leeway here, potentially they could have been used in Korea. I don't know.
Well, yeah. I mean, one of the things that I think Truman is not as well known for, and again, why I'm trying to write interested in this book about him, because he's more complicated. I mean, people assume, oh yeah, he used the bombs in Hiroshima and Nagasaki. There's a whole story we talked about last time, not exactly true story, about how he made the decision. He always defended it, and they sort of assume that, oh, he's this very about as pro nuclear as you get. And in some ways, he's not. And one of them is the civilian control. It's Truman who insists on not just civilian control, but presidential control. I mean, he very consciously intervenes at really crucial junctures to say, we're going to I don't trust the military to be in charge of this. And the military at this moment, frankly, does not give him a lot of reason for trust. I mean, people like MacArthur, but it's not even just people like MacArthur. Like someone like MacArthur is going to reinforce the idea that these generals are totally out of touch in Truman's mind about what these weapons should be thought about, how they should be thought, how they could be used. And they are trying through this whole period leading up to Korea to overturn civilian control to some degree. And Truman won't have it. And he's having his whole top advisors, the National Security Council, the Joint Chiefs of Staff, they're coming in him and saying, well, yeah, civilian control is great, but you should give us some nukes. Like, how can
Right.
we effectively do anything with regard to nukes if we don't have the nukes? And so they're building nukes in this period. They get started a little slower on that than I think people realize. They had very few nukes until about 1949, 1950. All of them are in civilian hands. All of them. Truman won't let them have them at all. And in fact, we can get into this. He ends up giving them access to exactly 9 nuclear cores. Exactly 9. And it's an interesting number. I spent a lot of time looking into this. Why 9? That's all they get total under Truman. So, and that's not until the spring of 1951. And interestingly, they don't even get more until like year 2 of the Eisenhower administration. Even Eisenhower doesn't initially give them access. And then by the end of the Eisenhower administration, they have 90% of the nuclear stockpile under their control. And so we could talk about how that happens. That's its own separate thing. But under Truman, they don't have the nukes at all. And they certainly don't have permission to use them. And the question keeps coming up, should we have them? Even the question of, should the president be in charge of the decision? Like, why should a president be in charge? And Truman just like shuts this down repeatedly. He's very, and not just for subtle reasons. He tells them to their face that he thinks they're being stupid about this, and that they don't understand this at all. And there's no way he's going to let them treat this like, as he would put it, like a normal military weapon.
Right. Right.
Um, Interesting. I mean, on the military industrial complex stuff, it's not as smooth a through line as you looks in retrospect. The way I would think about it is World War II, huge buildup. World War II ends, Truman wants to demobilize. He wants to spend a lot less on defense. He does not want some giant standing army. He's not interested in that. And so they start to demobilize very rapidly, which has all these economic consequences and things. The generals hate this. They want this big standing army. And Truman doesn't really think that's a thing. A lot of the generals attack the atomic bomb in this period, interestingly, and the use of it in Japan, because they think that if the bomb gets the credit for winning the war, people will think, well, if we just have the atomic bomb, we don't need a big conventional military.
Right,
So this is
right.
why you get Eisenhower, Leahy, a whole bunch of these people saying that they don't think the bomb was necessary, which of course is a different context than how we would read that today. This is a
Wow.
pro-military, and it's not until around 48 that one the they start to warm up to the bomb as they start to get more of them and start making plans for using them. Um, it's only sort of after the Soviet nuclear test in 49 that they win this sort of battle to stop demobilizing and to start going the other direction. And then the Korean War happens and we sort of like get this giant mobilization. And so it's this interesting, I really love this period, this what might be called just the post-war before the Cold War, because it's really not clear what's going to happen next. It's not unambiguously clear that it's going to be this Cold War thing. It becomes that, and maybe it feels a little inevitable after the fact for a lot of reasons. It could be. But like at the time, there's all this internal friction about this question.
Well, maybe this is a stepping off point to talking about again that scaling up. Maybe you start with kind of, well, I don't know. You can start either with the sort of scale of destructiveness or just the sheer numbers that are being added, because it seems to go pretty quickly if they're hitting a kind of 20-to-1 ratio by the Cuban Missile Crisis.
Well, it's really interesting. So you have the Manhattan Project, which is this massive. It's like creating a new industry overnight. Almost, it's not overnight. It's 2.5 years, but that's still like a lot to create something that's a significant chunk of American industrial production. It's like 1% or something of American spending and employment, and like that's a big chunk to create in just 2.5 years. And it's all about getting the bomb ready for World War II. So they're cutting corners, right? They're not doing things the way you would do it. They don't know what the right answer is always. They are not thinking about the future so much. They're just trying to get it done for that minute. And so they're cutting corners in a lot of ways, including things like waste storage. They store the waste really poorly because they're like, somebody will take care of that later. Turns out they don't, but whatever. But even things like the reactor designs, they at Hanford, they don't really know how to run industrial sized nuclear reactors. This is the first time they're doing this. And it turns out there's all these problems that crop up that they don't 100% know what the answer is. So it turns out when you run those reactors for a while, the graphite swells in complicated ways and endangers things. So they like turn the reactors to half power for over a year, trying to figure out what the answer to this technical problem is that they didn't anticipate because they never did the sort of the pilot work. These are just scale to full size immediately. And of course, you have issues with that. At the same time, at the end of the war, people go home. Like the labor force was this wartime labor force of people willing to contribute to the war. This is both the regular laborers and operators, but also like the scientists. Like, yeah, they had a really interesting time at Los Alamos. Great time, right? Interesting job. Now they want to go back to their jobs, right? They didn't sign up to be permanent weapons scientists. So, like, Los Alamos empties out, except for the people who really enjoy weapons work for some reason. In this period, there's also not a lot of certainty about what is the future of the nuclear complex going to be, who's going to run it, what legislation is going to run it. Is it going to be about making weapons? Are we going to ban nuclear weapons at the United Nations? These are like actually open questions. The result of which is Congress does not pass legislation about this until 1946. It doesn't go into effect till 47. Until then, it's basically still the Manhattan Project, but being run on sort of a contingency basis without clear direction. They're not really building up much. They have a lot of problems at their existing facilities that they're trying to sort of analyze and patch. They are not actively producing nuclear weapons in a meaningful sense. They are still producing fissile material, and some of it they're making in the little cores, but they don't have all the parts. They don't have all the facilities for making. They certainly don't have anything assembled. So by 1947, so now 2 years practically after the end, the Atomic Energy Commission becomes in charge of all this, and they go and they ask Los Alamos, how many weapons do we have ready to use if we needed to use them? And the answer is zero. Zero. They have zero weapons at all. They have like the fissile material for maybe 13 weapons ready to go, depending on how you define that. But they are not even, they also are not making any gun type weapons. So they have a bunch of uranium and they don't haven't really done anything with it. So what happens is over this period, what the Atomic Energy Commission is trying to do is first just like regularize this thing. Like the first weapons from World War II are handmade artisanal nuclear weapons, right? Every little part is a guy putting it together. That's not how you do production of anything on a scale and reliability and all that. So they end up looking into, okay, we need like a contractor to do this. We need like full-time people whose jobs it is to like build the different parts of this, and we need to make sure we have the right facilities, and we need to make sure they're working correctly. And so they spend several years just basically getting the production on firm footing. And it's not until around like 1948 that they are able to produce the maximum weapons per year that the Manhattan Project was originally designed to produce. Like that's how far, so the production level goes down after World War II and doesn't come back up again until about 48 or so. The Manhattan Project was designed to produce about 3.5 weapons per month. And they end up by 47. I mean, they have again like 13 cores after 2 years. They're not doing that, right?
Right,
So
right,
they start getting it up by the late 40s. They then start looking into expansion programs. And so the way they just do this is basically like they make another Hanford, they make another Oak Ridge. These are these other factories that they end up putting together, Paducah, and I forget all of them, but there's a whole bunch of these little factories. And they get literal bomb assembly factories, which becomes Pantex, where like these are assembly lines for nuclear weapons. They are still using by 1949 this essentially the same weapon technology as they were using in World War II with like little tweaks. So it's like upgraded versions of the Nagasaki bomb that are easier to handle, can accept different types of cores. They've done some testing in 48 that showed them they already had ideas from World War II about different ways you could do the core to get more efficiency, use uranium and plutonium. You could make the core have a little air gap in it, which is called levitation, and it compresses it better. There's all these little tricks they figure out and they test in 48. So they make these like cores that could be interchanged in the weapon so that by then they can like double the yield of the weapon if they want, or use half the fuel and so have twice as many weapons. But they're still like the size of a small car. They're clunky. They're not that powerful by nuclear weapons standards later. What changes in the early 50s is one, all of these new production things start really ramping up and going online. They start getting more and more. They build another. They I think they build like two more Hanfords. Like they build bunch like just duplicate fissile material production facilities. They get full time like big factories that do nothing but do the electronics. Like they start like really treating it like it's essentially like a car where every little
right,
part is
right.
made assembly line. And then they also start having all this innovation in weapon design. So that's when you start going down the direction of both really small weapons and also the H bomb, the thermonuclear weapons. And so by the 50s, you now have all sorts of possibilities opening up. By the early 60s, they can make such a wide range of weapons for any kind of application. So by the early 60s, you have weapons small enough that a single person could carry them, man portable nuclear weapons, and also weapons that are measured in, they have basically a 23 megaton bomb that is about as big as you could probably need for anything, and a plane could carry two of them.
Wow.
And they are starting on like things like long range missiles and delivery mechanisms and everything in between. They have little weapons that are air to air missiles, like that kind of thing.
Right.
So, and by the 60s, they can produce um, thousands of weapons per year. So like they've ramped up production. So you're doing dozens of completed nuclear weapons per day. So, but all of that took time to put in place. It took 15 years or more to get all of the infrastructure, both human and material, in place that you could get to that stage.
Yeah, it was interesting in prepping for this. I was watching some videos about broken arrows, and they were talking about how the Sputnik program created a ton of anxiety, and it
Yeah,
really sped up, how quickly you needed to be able to get your bombers in the air if you wanted to have a first strike or a response, or not have your air bases wiped out. And so they were talking about how the cores used to be stored sort of separately from the bombs, and then
yeah,
they were put together, and that led to a few famous incidents. I don't know if you want to kind of jump into that a little bit, but
sure.
I found the broken arrow thing pretty fascinating. Some
It's really
bombs dropped
interesting.
on Canadian and U.S. soil.
It's really interesting, but it also gets back to this bigger political question. So, the Atomic Energy Act of 1946 says that the president is the only person who can authorize the transfer of fissile material to the military. And again, Truman wouldn't do it. And so, what do you do in that situation? And what they come up with is the system where there's the sort of non nuclear weapon that then you can insert the plutonium or uranium into and make into a nuclear weapon. And so some of those, I mentioned that they modify the Nagasaki bomb. One of the modifications is to make it really easy to just plug that sucker in. You don't have to do this big complicated assembly procedure. Um, and so this is an interesting case for me. Oh, I hate these little gestures. I don't know what causes them. Okay. I gesture too much and my computer puts a weird, so irritating. One of the I find it really interesting because it's a like technical solution to a political problem, right? So like the political requirement is you have to keep these functions separate. The technical requirement is we need to be able to assemble them very quickly. So they actually physically enforce that civilian military separation and make it sort of plausibly work. Um, that goes away with what are called sealed pit weapons. So a sealed pit weapon is the pit is the fissile material. These are weapons where like the pit is always inside the weapon. You can't remove it. It's like sometimes glued to stuff, right? Like, and what you get out of doing that is you can make much more compact weapons, and you can have the weapon be in some ways much more efficient use of material, without and in different shapes and all sorts of stuff that would be not possible to keep it separate. And that's one of the factors for why they start transferring so much to the Department of Defense under Eisenhower, is that the weapon design no longer accommodates this. You could ask, could they have made weapons that accommodate this? I mean, within certain limitations, right? There'd be always an engineering trade-off, but I always think it like this is a choice that was made that eliminated one distinction. Um, to get to your accident things, there are a bunch of accidents, and there's a several like ones at the there's a huge number of what we could call accidents, uh, and their severity depends on how you think about what's going on inside of them, and they're caused by different things, and they can be anything from the plane accidentally drops a nuke out of it, which happened, to like a guy was handling a nuke at a factory and dropped it. Like that's a different kind of accident. The plane ones are the ones that usually get the most attention because those are usually happening not at like a US military base. Uh, and the whole idea, from the beginning, the idea has been that yes, these weapons could be dangerous and are so powerful, but don't worry, we have control over them. And the accidents seem to indicate the limits of some kind of control, right? They're
And that's
often
that's that's partially a product of just the sheer number that are around and how many are kind of permanently in the air. I guess as Bomber Command is sort of ever ready to launch a strike on Russia. Is that? I mean, I'm sure
some
there's a
of it's
myriad reasons, but
yeah, some of it's that. So definitely, if they start in the late 50s and early 60s having these constant patrols where you always have some bombers in the air, and of course, planes have an error rate, an accident rate, human mechanical failure, whatever. And if and for some of these planes, it's like a very well-defined rate. Like they'll have some catastrophic accident every so many flight hours, just as a probabilistic number. You can figure this out. And then you say, okay, well, how many planes are in the air for how many years, how many flight hours? And you work backwards and you say, okay, if these have live nukes on them, you'll get one major accident a year. Is that a worthwhile trade-off? I don't know. But like that's sort of, and the sorts of the accidents can come from anywhere. There's this whole idea out there, which I'm sure you've heard of, the normal accident theory, sociologist Charles Perrow, where basically the idea is that in any like sufficiently complicated nonlinear system, um, you will have the chances of things going wrong. And usually your system can accommodate for something going wrong. But if you have too many things go wrong at the same time, especially unanticipated things, then you get this accident that looks incredibly specific and weird, but is actually normal in the sense that you would expect that, yeah, there will be an intersection of five weird, unexpected things every so many hours if you have a system of sufficient size and complexity, and has all sorts of human and technical factors going into it. And something like an airplane, which has just like a lot of things on it, especially at this period. This is not, I want to say, it's not a slick, safe commercial flight like we have today. But of course, we've been having some issues today with supply, issues with these systems. But like, these are also military planes, which have a different level of risk tolerance and earlier generations. I was reading about a few of these recently. I sometimes go down a little rabbit hole on some of these, and it's just fascinating. So there's one in called the Mars Bluff accident, which is one of the earliest well publicized ones. It was actually like the 13th major accident, but like it wasn't, the others weren't well publicized. Where this bomber is flying around, I think it's in 1950, and they get this, they have a bomb inside of it, and they get this error light comes on in the cabin that says the electronic bomb release mechanism is malfunctioning. And so that's not good. So they send back the navigator or something to go put in, they have a way of putting in like a manual pin in there so that even if that for some reason that release opens, it shouldn't drop the bomb, it'll like secure the bomb. And he's trying to do this in this unpressurized bomb bay. And he's like reaching around with the pin, and there's different accounts of exactly what goes wrong. But in the process of trying to insert the pin, he ends up releasing the bomb, which falls to the bottom of the bomb bay and then breaks open the doors. The guy is hanging on in there because he's not secured in any way. And finally, the people in the cabin realize something's up. They close the bomb bay doors. The poor guy is okay, but the bomb falls into a small town in South Carolina, near Mars Bluff, South Carolina, near Florence, and detonates when it hits the ground. And detonates near a family's home. There's these people get somewhat injured by it. Um, you can't cover that up. Obviously, it's kind of a big deal. Now, this bomb does not have a nuclear core in it. This is before, remember I said Truman only gives them 9 cores in 1951. This is 1950. It like literally could not have a nuclear core. Even in the plane, they don't have nuclear cores. The
Wow.
military doesn't. So there's no possibility that had any nuclear impact, um, in the sense of a nuclear chain reaction or anything. There's a little radioactivity from the tamper, which is made out of uranium, but nothing serious. Um, but it does have like, you know, 2 tons of high explosives in it. And those are what detonate and leave a little crater and things like this. So on the one hand, like that's a screwball accident, right? That's a weird set of circumstances. And also literally no chance that that could have had a nuclear re- explosion as a result. But it's also indicative of like, okay, this is not as in control. And also, once you start putting those sealed pits in, you have to start thinking a lot more carefully about, would a weapon under those what they call like abnormal conditions have a chance of detonating? What do you have to worry about in those situations? Are there ways to make it less likely, etc.?
And it sounds like, I mean, there's been some other near misses. I'm thinking of, I think, Titan ICBM. I think it was like a 3 megaton bomb, where some
Yes,
repair
in the
people
80s. Yeah, yeah,
dropped
yeah.
a ratchet head, and anyway, the whole kind of propellant of this ICBM blew up and launched the nuke out. And there's like 3 or 4 mechanisms that have to go off to actually get the nuclear warhead to explode, and that never happened. But did we get close? Like, did a couple of those mechanisms trip? And I just imagining sort of a domestic U.S. nuclear explosion of
Yeah.
the several megatons would have had some pretty serious impacts on how history unfolded.
So the closest that I have looked at is the Goldsboro accident, which is another one of these famous ones. And this is in 61. And this is one of those planes that's on one of these always in the air missions. It's taking part in them. It was one called Coverall. Later, they called them all Chrome Dome, but this was when they still had different names. And it had some mishap in the air relating to refueling, and it was refueling, and then it was leaking fuel, and so they were going to return to their base, this big plane, and as it was trying to go back, they started to lose control of this plane. The people in it got out of the plane. Um, and as it was sort of going back towards the base, it like broke up in the air, this plane. And as it broke up, it had two H bombs inside of it that were, I think they were, yeah, 3 megatons or something like that, 2 megatons, something in that range. I haven't looked it up right now. And these two H bombs, they're sealed pit. They are fully complete bombs, but they also have all these little safety systems built into them by this point. They're not all the safety systems that would later be built into them. There's this tension between the military and the people in charge of the safety. The safety was mostly done by the people at Sandia National Lab. So these are the people. So Los Alamos like invents the bomb concepts. Sandia is the people who package the actual bomb up. So it's the electronics, the fusing, the safety mechanisms, how you fit it into what shape is the best shape to hit your target. It's all of that, the non-nuclear stuff, essentially, and the final packaging stuff. And there's this tension that was going on where the military didn't want anything that might prevent a bomb from going off when you wanted it to.
Right.
Whereas the scientists were like, I think it's more important that we make sure the bomb never goes off unless we want it to. And these can be intention. And at that point, there was perhaps more emphasis on the bomb being able to go off than on the bomb, would it intentionally than not going off unintentionally. Anyway, so these two bombs are thrown out of the plane. And interestingly, they have sort of different histories in terms of how their switches go. And Sandia does a complete postmortem on them afterwards, digs up all the parts, and they're very interested in using this to figure out the safety. So one of the bombs, the one of the things that's supposed to keep them from ever detonating accidentally is that they have these like switches in them that determine whether they'll fire or not. Um, so there's two. Let me just back up one second. There's kind of two different ways in which a bomb could detonate accidentally. And I think people sometimes don't know about the second way. They know about the first way, and it makes them misread this. The first way is like the Mars Bluff one, where the bomb doesn't do anything with switches, but it hits the ground. It's got explosives in it. Those explosives go off. Could that make a nuclear weapon yield? And the answer is usually probably not. There were some weapons that might have had a higher chance of that because they were not designed around that kind of safety in mind. They had like too much fissile material. But in general, you need a pretty symmetrical explosion, and you're not going to get that from the bomb just like randomly having its explosives go off. The coordination won't be there. But again, even then, it depends how you design it. There's ways in which you can design it so that it's not what they call 1 point safe. Just inherently, it depends on how your bomb is set up, but
Yeah.
most of them are set up so that they wouldn't be able to possibly, I think it's like 1 in a million chance that they could have a nuclear chain reaction from that kind of like blunt explosion.
Okay.
The other way is the scariest way, which is your bomb thinks it should detonate and runs the full electrical system. That's not like an accident. That's like the bomb is like, hey, I'm ready to go. Let's fire all this perfectly the way we're supposed to. And there's ways that can be triggered. Either we'll talk about the Goldsboro one, but even like some of the early bombs, if they got hit with lightning, they could have triggered their firing system, because it turned out there were like shorts between the firing system and the wall of the bomb, and you only needed a certain level of wattage and it would turn on the motor that starts the whole system and charges up the batteries and all these kind of things. There were bombs that they later found out if you like heated them too much, it would turn on the electrical system because they use thermal batteries. There's bombs where the Sandia people found that like if the bomb was on fire for a certain amount of period, the electronics could melt, the soldering fluid could go through and create a short that might turn on the electrical system. So that's, to me, that's the category people usually forget about. It's way scarier than the first category. I'm willing to say, like, sure, you could engineer away the first category, but the second category is a different kind of engineering, and they get good at doing that. So, like, later bomb systems have what are called weak links in them, which are like systems that will fail under certain circumstances and render the bomb a dud. So, like, if the bomb catches on fire, it'll melt some crucial part, and the bomb can't work without that. And now you're safe from everything else, right? Anyway, so one of the systems in place to keep the electrical system from even engaging is that it has these like rods that are meant to be very hard to pull out. And so you would have to be like deliberately pulled out with like a lanyard in the cockpit. They'd pull a thing and would pull a bunch of rods out, and that would allow the thing to begin the arming process. And in both of the bombs that fly out of the this plane at Goldsboro, the sheer force of them flying out pulls out those pulls.
Jesus. Yeah.
So in one of them, that happens really early on, and it starts going through the firing sequence. So it's and the way its firing sequence was set up, I don't have the whole checklist in front of me right now, but there's a whole bunch of things that it needs to do. For example, it needs to run out a timer. So this is to make sure there's a separation from the aircraft before it does anything else. It needs to start charging up batteries. And there's two separate kinds of batteries it has. There's the battery that starts up some of the firing sequence stuff, and then there's the battery that like charges the condensers that will set off the actual bomb. Um, it needs to know its altitude in the air. So it's taking like altitude measurements with barometric sensors to know that it's about where it ought to be before it continues on the firing sequence. There's this whole chain of events that it has to go through. The final of which, if it goes through all of them right, it fires the bomb. Now, that first bomb goes through almost the entire chain of events as if it was set to detonate. And the one thing that fortunately was there's a what's called an arm safe switch. And so this is an electromechanical switch that is armed from the cockpit. There's a little button in there that turns it on, and it's normally in safe mode. And if you give it a very low voltage, I think it's like 12 volts or something signal, it'll switch to arm mode. And when it's in arm mode, all these other electrical signals go through it and do things like charge all the other batteries and insert tritium into the core and then eventually launch the weapon, and even make it so that if the weapon contacts the ground, there's a switch there that if that other switch is open, will then send the signal and set the bomb off. And it goes through all of them. And fortunately, that switch is in the safe position. And so it stops. And so that bomb very neatly lands on the ground. It has a parachute open up and it lands and it tries to send the firing signal and it fails because that switch is there. And so it doesn't detonate. Good
Wow.
times. So
Wow.
that's bomb one. Bomb two, its parachute never deploys. So it also goes through the firing sequence, but it doesn't have as much time because it's going so much faster than it's supposed to. And the firing sequence doesn't start until I think later than the other one because it comes out of the plane a little later. So it doesn't run down its timer and go start a bunch of other things before it impacts with the ground. And it impacts hard because it doesn't have a parachute. And so it goes through the mud into the ground. There's no explosives. It's high explosives don't go off, which is good. You can make insensitive high explosives. I don't think it had those, but like they weren't they didn't go off by the impact. And it breaks up deep into the ground and it's hard to get at. So like those are these two different bombs. Now, when the Sandia people get there, they inspect these and they're quite interested in this. And they're very happy that this arm safe switch succeeds, but they're also not happy that they had all these other little safety things that were meant to make it really unlikely that you'd even get to that part. And so they sort of conclude like one switch, that's it. That's all that kept
Right.
this from going off. And they would note, and it's not me noting this, it's the Sandia engineers, that particular model of switch was known to be faulty and easy to trigger through like ambient electrical signals. Again, it's very low voltage switch. And in some cases would spontaneously turn to armed. And so you could imagine a world in which you got very unlucky and it happened to do that, and that weapon went off. The other one, because it didn't actually go through the whole sequence, had no chance of going off. But interestingly, when they dug it up, which took several days, they never got part of the weapon, by the way. There's part of the weapon that's still buried 60, 80 feet down in some mud, and they just gave up, but the secondary. But they got part of it and they got the switch. And when they initially pulled it out, it said armed. And they said, "Oh my God, right? Like, what if this one had been that one?" But they
Right.
took it apart at Sandia and found that the impact with the ground had broken the switch. And it was just visually said armed. Electronically, it was neither armed nor safe. It was like just broken inside. So it wasn't actually armed, but it looked armed. So that's a pretty, yeah, yeah, they were pretty. There's actually one of the reports, I really love it. It's been only declassified a few years ago, where one of the guys looking at it, like the way he writes the report, he's like, at this moment, we wondered, why didn't it go off? And you're like, wow, that's a really disturbing, like, really? It was armed? And then it turns out it wasn't armed, which,
Right.
So
Right.
like the postmortem on this was, this is not adequate. So they were already, with the smaller bomb, knew it wasn't totally adequate and had already instigated a change that would add one more, essentially, check in there that would isolate the electrical system in a way so that this wouldn't be the same thing, the risk wouldn't have been there quite as large. And they basically took all the ones that didn't have this applied and said, we're going to take those out of circulation until they get applied. In later bombs, by like the 70s, they have many more things in place so that the electrical system is way more isolated. And again, if something weird happened, if it's coming out of the plane and it's not the right altitude, like it won't even start to, trigger the sequence. They added a lot more safety things, though. Even as late as like the 90s, there were some weapons in the stockpile that had basically like a C or a D rating in terms of safety, in terms of accidental detonation. All the ones now are like extremely designed around the safety. The explosives are insensitive. They have locks so that you have to put in the password correctly, essentially. And like, there's a lot of little
Yeah.
tricks they've
Yeah.
they've used over the years. So I'm not that worried about that today. I just want to emphasize. But
Okay.
the ones in
Yeah.
the 60s,
Wild West. Yeah.
uncomfortable. Yeah.
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 Okay, well, we've been pretty granular here, and I'm a little bit conscious of time. It's still
Yeah,
totally
it's fine.
fascinating, but yeah, I'm super curious. Like, like the stockpile. I'm sure when 10, 20, 30,000 bombs. Like, what was the kind of natural limit? Why did it sort of snap back from that? And also in terms of just sheer size, Sarabamba was the biggest weapons test. But why stop there? Like, what was the decision making that led to, I guess, our contemporary reality of kind of the number of bombs and the kind of maximum yields of our bombs?
So the period from about 1950 to 1961, I sort of like to call that the exponential stockpile, because it's got this just exponential growth rate. And then around 61, they stop exponentially building weapons. They still build a lot. I mean, the stockpile is still very large, and they're still adding weapons into the stockpile, but they're also taking weapons out of the stockpile at the same time. And so the number goes down, even though they're continuously in and outing. Um, and I th- I've been very interested in like what are the conditions that produce that growth, and then also what are the conditions that stop that growth. And part of it was concerns with things like safety. Like every weapon you have is a weapon that can have a mishap, that could go missing, that costs money, that needs a purpose and needs to be justified. And at some point, how many do you need? Of that number, I would point out like at its max, like 50 to 60% of those weapons are tactical nuclear weapons. So they're small. They're meant for battlefield or even like air to air or torpedoes, that kind of thing, not strategic weapons. So that's one of the explanations for why it gets so big is we go very in on tactical weapons. And then we start to sort of pull back on that because it turns out that like having lots of troops with very small weapons that are hard to secure is like by the 60s, people are starting to fear accidental nuclear war, right? Some guy
Right.
accidentally, or for what, there's a reason Doctor Strangelove comes out in 64, right? Like it's
Right.
representing actual fears that were there at the time that some general or even lower could just make a really stupid decision. Um,
I've heard in terms of like the wargaming that in general when they run these scenarios, like a tactical use of weapons basically almost always leads to a strategic nuclear exchange and mutually assured destruction if it's the U.S. and Russia. Is that accurate?
yeah, I mean, when you do the wargaming. Now, whether that's reflective of what reality would be, I don't know, because it's impossible to actually capture. You don't actually have anything on the line in a war game, whereas there would be really people's risk. We don't actually know how people would react, and so like I'm saying yes, but there have been some interesting, more recent war games where the accounts of them have come out where people have said. So there was war game in the Obama administration that we know a little bit about. Fred Kaplan writes about this in his book, The Bomb, which is really interesting, where the old guard Cold Warriors, they all want to jump to nuclear. And then the sort of new post Cold Warriors are like, wait, wait, wait. Why do we need to jump nuclear so fast? Why don't we try a conventional reply? Why do we? So, like, it's interesting that I don't really know what would happen. I don't want to find out, but
Right.
keeping that
Fair.
ambiguity is maybe the best.
Yeah.
Um, the thing also about the bigger, just to throw one thing, the big stockpile before the 60s, the overall process was not super centralized. It was also very classified and kept secret even by the military. There wasn't even a lot of executive oversight. So if Truman is this like all civilian control, it swings really far under Eisenhower towards military autonomy. And this is one of the war plans are not even synchronized between the services. The Navy and the Army and the Air Force have their own independent war plans. In the 60s, they start centralizing it. This is the Kennedy administration. Some of the end of the Eisenhower too. They becomes the PSYOP, the single integrated operated plan. Part of the effect of that is you stop that exponential. Nobody's actually looking at the big picture growth, and you start having to justify everything. And so I'm not saying it gets rational, but that puts a damper on just endless growth on it.
And speaking in terms of growth of yield,
Yeah.
I mean, how big are the biggest bombs now, and why did they kind of arrive at that size? Why did they settle out there?
So there's this enthusiasm in the 50s and 60s for bigger is better, especially after first making the H bomb. And we sort of deride the Soviets for this, but the U.S. in the 50s, there were people in the Air Force who wanted 60 megaton bombs, and this was a serious consideration. And basically, the president shut this down. Eisenhower was not interested. Politically too problematic, and the applications weren't that obvious to him. You can also make more bombs that are still plenty big. We did have these again 23 megaton bombs. The difference between 23 megatons and 60 is not as big as people think it is because the yield doesn't scale linearly. So like two 23 megaton bombs is essentially more flexible and the same amount of damage as your 160 megaton bomb.
And are these basically doomsday devices when they get that large in
No,
terms of like the strategic use?
no, they're just really big, but they aren't like world killing. They do look at the possibility of not necessarily world killing, but what I think most people would call doomsday devices. So in the 50s, in the mid 50s, through the late 50s, the scientists occasionally float the idea of gigaton range nuclear weapons. So this is 1,000 megatons. And Edward Teller, one of the inventors of the H bomb, he actually pitches a 10 gigaton bomb, which is they call the sundial. And he pitches this actually right after the Castle Bravo accident, which is probably not like your best tactical move. You're like they're already like, what went wrong with our bomb that was bigger than it should have been? And then like, hey, but what if we made it even bigger? And you're like, okay, Edward, calm down. And interestingly, they bring this up in the Eisenhower administration, even just the idea of a 1 gigaton bomb, and the Eisenhower Air Force just has no use for this. They believe in fighting a winnable nuclear war, and doomsday weapons are not a winnable nuclear war. So, like, why would you do this? And to put it into context, 10 gigatons, that's like pretty much the size of the entire US nuclear arsenal in the 60s. Maybe a half the size or something, but like that's a lot for one bomb. And it's not clear how big that would have been also. It's not that deliverable. I said that the damage doesn't scale linearly with yield, but the weight basically does. And so like this is and volume. So like this is a barge or something, right? This is not a fits on
Right.
a missile. What happens is they get missiles, and missiles put a priority on the smaller your package,
Right.
uh, the easier your missile is. And also, as especially as missile defenses start to get floated, they start doing things like MIRVing, where you're putting like 10 individually targetable weapons onto one missile. And if you do that, your priority starts to be volume and weight, because you want to fit this tiny compact package, and any weight increases the amount of fuel, and it makes it more difficult. And then accuracy. So you start having this drive towards more accurate missiles. And what you end up with is kind of a sweet spot with, if you have really accurate missiles and you want a bomb that sort of fits into maybe like a large trash can and has enough explosive power that you can knock out whatever you want. If you have high accuracy, you don't need huge bombs. You could
Right.
have a couple still quite large bombs, and you'll destroy anything worth destroying with that. And so the sweet spot ends up being in the sort of hundreds of kilotons. So most of the weapons today are between like 100 and 500 kilotons. The US has maybe one bomb that's megaton range. The Chinese don't have as accurate missiles, so they compensate with some yield. They might have a few megatons. The Russians might have a couple megatons. But generally, when you get to a certain type of nuclear power, the technical your delivery vehicles mean are what determine what's optimizing it. And so it's better to have a lot of 100 kiloton weapons than it is to have a few gigantic. A Tsar Bomba, they couldn't even fit into a plane. That's not good delivery. You shoot down the plane, right? Like, you see the plane coming with a giant bomb under its belly.
Right.
That's the biggest
Right.
target that's going to be there, right? That's going to be really hard to get to a target. Whereas a submarine launched ballistic missile or a cruise missile, there's no really very reliable way to try to avoid that destroying you. So,
What about like the collective power on board a ballistic nuclear submarine? I mean,
yeah,
this is just a wild platform. And I don't want to like get too much into like the nuclear triad, but you hear of a lot of countries that were pursuing nuclear weapons. A lot of them gave up for a variety of different reasons. It's really expensive to deliver these things. But
yeah.
yeah, I mean, I'm particularly interested in the submarine launched ICBMs and just the destructive potential on a single vessel like that.
Yeah, and I'll just emphasize on delivery. If you look at like how much money the US spent on nuclear weapons in the Cold War, we spent way more money on delivery than we did the weapons themselves. It's way harder to build a fleet of submarines full of submarine launched ballistic missiles that are accurate and all this kind of stuff. And staffing them, that's way more expensive than just once you've got your gaseous diffusion plant churning out more uranium or assembling the bombs or whatever. Those are not the expensive parts. I mean, they are expensive, but the delivery, rocket development, plane development, fielding weapons, way more expensive by like an order of, it's like 3 times more expensive. Uh, so it depends on what era of submarine and weapon and warhead, and also how many. So our missiles can have a lot of warheads on them, but we don't necessarily keep them fully stocked. There's treaties that dictate how many warheads we are allowed to allocate to just in total. And so we don't always allocate the maximum. So a lot of our subs for a while have only had like 1 or 2 warheads per missile instead of like the full 12 or whatever they can take. But like I did the math for one in the 70s just as an illustration once, where it's like, okay, let's take like what was that era. And I don't have the numbers right in front of me, but I came up with something like 90 megatons worth of weapons on one Ohio class submarine in the 70s.
Yeah.
Maybe I'm a little off. Maybe but like it's basically a Zarbamba submarine, right? And I like to bring this up because we like to make fun of the Zarbamba, like, oh my God, so ridiculous, so many megatons, so pointless. And like, yeah, sure, it is in many ways. And the US flirted with making its own weapons that big too at the same time, because I don't know, there's something to that maybe. But we and even the Edward Teller stuff, the gigaton range stuff. Oh my God, so ridiculous, a doomsday machine. But like, we still built things like this. We just broke it into a lot of different pieces. And Dan Ellsberg, the late Dan Ellsberg, he made this argument, which I think is right, which is like, we still built a doomsday machine. We just didn't do it in one machine. We did it in a system. And it would still be, this horrible thing. And I think that's a valid way to think about it. I mean, and it's interesting to think about why we think one of those sounds like more reasonable than the other.
Right, right. Okay, well, let's get into command and control
Yeah.
because I think that's a fascinating area. I'm sure it evolved a lot over time. And again, I'm just curious if like, this is obviously so secretive, like within each nation, but like have best practices diffused because it's pretty important.
I mean, we don't really know. That's the
Right,
problem with the secretive stuff is it's been a source of concern for a lot of American analysts over the years is we have had all these accidents and problems and command and control issues.
right.
And we are not the most transparent about these things, but we're way more transparent than any other country about these things. You can read up, I can FOIA the accident reports and like we've released information. Sandia has a great little documentary. You can look it up on YouTube. Always Never. It's like a 3-part in-house documentary on command and control and safety at Sandia by Sandia Nuclear Engineers. It's pretty
Wow.
good. It's not the whole story, of course, but like it's pretty good. Um, Other countries are not transparent on this for the reasons. One is they don't like to admit to lack of control for probably good reason. I mean, you can see why that makes it hard. But also, there's a fear that if you know about how a nation sets up its not just its safety issues, but how it sets up its nuclear launch procedures, which are pulled into all that they're all command and control is all of these things intersecting. It's everything involved in how you would order a nuclear weapon to be used, but also how you keep that from not happening when it's not supposed to be used. Um, if you know too much about that, in principle, you can defeat it, right? If we know that, that their weapons can't be used unless this signal goes from this person, then we jam that signal or kill that person or whatever, and maybe they can't retaliate. That's the fear. And there's ways to work around that, of course, but they're also kind of scary. Like, let's have a lot of redundancy. That's not necessarily a safe thing. Anyway, we don't know Pakistani command and control, right? We don't know. I mean, probably the CIA has some ideas, but like we don't know North Korean command and control. One of my favorite jokes, it's not really a joke, but like if you think a North Korean nuclear weapon system is scary, imagine a North Korean early warning system. Like our early warning systems in the 70s were literally giving at least one false alarm a week. Like that's
Jesus.
right. Like that's a little
Yeah.
terrifying, and they're not as bad. Some false alarms are scarier than others, but like how good do you think the North Korean early warning system is, right? How many false alarms do you think it gives them per week, right? What would you like it to do during a crisis? Um, yeah. Uh, we have over the years, what's happened is that I think if you're going to make a criticism of U.S. command and control as it currently exists is that it's very patchwork. So it's not like they sat down with one master system and were like, here's the ideal system. It's more like over the years, these systems have had different things added on to them to deal with different issues. Like, how do you communicate with a submarine that's on the bottom of the ocean? Well, really long range radio waves, long frequency radio waves. You need like huge antennas, miles long to do that. So we built systems, physical ones, and also the president's like emergency war plane can stream an antenna out the back of it. So that's like a mile long.
Wow.
Yeah, which I thought was pretty
Wow.
crazy. So like, but that system was sort of developed at one time and then thrown into this mess of other systems, which are all technical human hybrid systems, of course, that date from different eras of development. So some of it is relatively up to date and some of it is really out of date. And there's advantages and disadvantages to that. I saw one of the top people on this in the military give a talk once, and he one of the things he said is, well, like you can't hack 10,000 miles of copper cable. Like that's not a hackable situation. On the other hand, we're still using floppy disks, like the big ones. Like maybe that's not ideal. Like some of these systems are really old and there's only one guy who knows how to fix them, or they're from the 70s or the 80s. How many computer systems do you want to use today that are from the 70s, the 80s? On the other hand, new systems we know have like an infinite number of security breaches possible. And oh my God, do you really want this on the internet? And there's all sorts of like some of these are the same concerns that you get in any high risk infrastructure type situation. So, to get more into your camp, like a nuclear power plant will have systems that are it'll a lot of nuclear power plant. I don't need to tell you this, but like
Yeah, yeah.
the infrastructure, a lot of it's from the 70s, essentially 70s design, with then has been updated with sort of modern computer systems on top of them, some of which are air gapped with computers that are on the internet. So you can check your email because you got to check your email. On the other hand, you don't really want the control systems to be on the internet. And so there's like, I visited, I think it was the one in, is it Vermont? I can't remember the name of it. There's a plant up there, but they showed us the little simulation room and they showed us like, yeah,
Yeah.
that machine would be on the internet and that machine is not on the internet. And then of course your computer security guys start immediately saying like, yeah, I bet I could figure out a way to get my virus from there to there. And like we did, that's the Stuxnet thing. You put them on USBs because at some point somebody's going to need to transfer some files between the two. So hit that vector really hard and give out free USB keys at conferences. And like, yeah, if you work in the nuclear industry, never use a USB key you got from a conference. But like that's how we got Iranian centrifuges shut down, was by like bridging that air gap. And anyway, the point is that like it's easy to come up with something that looks like a safe system, but of course there's really lots of ways to compromise them with modern stuff because it's just more complicated, which gets you back to the normal accidents thing. So anyway, like right now, the U.S. is planning to spend and has started a program of spending a huge amount of money to modernize the command and control system. And I'm not sure anybody knows 100% what that is even supposed to look like at this point. Like, is it one new system to rule them all, or is it a bunch of subsystems that are all, kind of separate? And like there's different philosophies you could use to approach that kind of thing. But the fear is that this has not been really modernized that much for a while. And, you're having that's a lot of potential, a lot of potential consequences you're putting onto these very old computer systems.
So it's probably like, again, beyond the scope of answering in a few short minutes. But in terms of like an order moving its way down from
Yeah.
the president, the nuclear football, like just from a like 30,000 foot view, what does that look like?
Yeah,
If you
sure.
were if they were going to order a massive retaliatory strike or something like that.
Yeah, or any nuclear attack. I mean, it's the same
Sure.
kind of thing. Yeah. So, what we know about this, and there's a big caveat around this, where some of the stuff is essentially declassified or written in some way that we feel somewhat confident that it's real, like doctrine manuals and things, and congressional testimony and things like that, declassified documents, etc. And then some of it is people have said things in interviews. Maybe it's part of the story, maybe it's a full story. Sometimes people have said things in interviews that seem false. Maybe they don't know. It's also possible people within the system don't know the full story always because it's compartmentalized, et cetera, et cetera. So there's big uncertainty bars here. But here's how I understand it, having looked at it a bit. Um, if your president wants to, so the president has to authorize the nuclear usage. The one caveat here, and this comes up in Eisenhower and Kennedy and potentially some later ones, and we don't know if there's anything like this today. There may be situations where the authorization has happened ahead of time. So what's called pre-authorization. So Eisenhower, for example, basically said under certain conditions you can use nuclear weapons and assume I gave you the order. So in principle this would only be used for things where like you can't get in touch with the president and there's unambiguous the war has started,
Right.
or something like shooting down enemy planes with your nuclear tipped air to air missiles. Like that's not as big of a risk, right? Uh, but in principle, president has to authorize it. Everybody agrees on this. No question. They're the only person who can instigate an order and who can authorize an order. From there, depending on the circumstances, there are different accounts about how that order ought to propagate or might propagate. And what strikes me as most likely is that there are redundant ways to do it, because you don't want a system that's so rigid that if it has to go to this guy, but you can't contact that guy, that you can't do anything. Um, the value of the football, by the way, the football is for when the president is not near the Pentagon or the White House. If the president is near the Pentagon or the White House, or on his little mobile command center plane, I keep forgetting the name of it, you don't need something like the football. The football is for authenticating the president's order. It is the president, and it also the bag, which is heavy, probably contains as much information as you could need to figure out what the order ought to be, right? What nukes do we have? Where are they? What can they hit? It's probably got the plans in it, so the president can say, I authorize plan 84C. They already have worked out a bunch of prearranged scenarios. Um, it's the sort of mobile president authorization. So it's not absolutely necessary. If the president is in DC, he probably doesn't need the football, right? He goes to the Pentagon, he's there with these people. Um, the pathway, depending on the sources you're looking at, some say the order should go through the Secretary of Defense. It's very clear it doesn't have to go through the Secretary of Defense. The Secretary of Defense does not need to give their assent on this. They cannot veto it. They can't even park the order and not follow it through or something, because they are absolutely not required for this chain, whatever. They're it's not the normal chain of command. The other people it is meant to go through or could go through, the one that is listed in various Air Force doctrine, is the chairman of the Joint Chiefs of Staff, which is not necessarily just a person, but could be sort of the whole office. Um, the other is the head of Strategic Command, who is this is the branch that's in charge of the actual missiles and things like that. And then from those people, the order gets relayed to through whatever systems, command and control. I was just black boxes as like computers and satellites and wires and whatever. That
You said
order
10,000. You said like 10,000 miles of copper wire. Like what?
there's
I'm like, yeah. I'm
across
less
the
interested in
United
like,
States. Yeah, I don't
yeah.
know exactly how many miles, but it's a lot.
So it's like a network of like telephone wires that are dedicated just to this. Is that
Hardened,
accurate?
buried, nuke proof, EMP proof. Yeah. Yeah. There's
That's
some
insane.
Well, that's how you have to do, because
Yeah.
otherwise, what if they set off an EMP and also have saboteurs crack the wires or whatever, right? Like then you've disabled it. So system is built around the assumption that you might be under hostile nuclear attack, and it's got
Right.
to be able to survive that and any sabotage, any hacking, any whatever. That's built into the assumption of how this should work. It's also why, in principle, I have heard from somebody who knew about these things, he's deceased now, that like the president could call up the guy in the silo and deliver the order that way, right? Like there's a lot of intermediary steps, but there's
Right.
also
Right.
sort of
Fallbacks
infinite
and
variation. But eventually these orders go through to, if it's a missile or a bomb. Now, the bombs and the missiles, not necessarily the submarines, but they have like unlock codes where like the launch control center guy, uh his boss needs to approve some code that goes through so that the missile is armed, and things like this. There's other little things that happen in here that I don't like. The details are sometimes known and sometimes not, and aren't as interesting to me, because to me the core political question is, can the president do it on his own? And the answer is, in some sense, no, and in some sense, yes, right? No, in the sense that like there is this huge system that needs to. The president is not actually launching the missile. It doesn't work that way. It shouldn't work that way. There is no red button on the desk that
right.
wires a signal. On the other hand, this whole system is set up to immediately, quickly, and reliably translate that order into a result. The people at the very top, the chairman, Joint Chiefs of Staff, Stratcom, probably not the Secretary of Defense, but like those people, you could imagine them just disobeying an order and
Right.
suffering consequences for that or whatever. Like that would be a crisis. It's clear they don't have a plan for what that would look like worked out. That's certainly not part of the doctrine. But I don't see anybody after them doing that because they are drilled to just literally what they do is drill for doing the order, the checklists, so that if the order comes through, it's automatic. They don't question it. They're also, when you get missileer training, one of the things they train you to do, which we know because some of this has been declassified, they train you essentially not to ask questions about this and to assume that, like, look, your job in this is not to evaluate the global situation.
Geopolitical.
You don't
Yeah.
have the
Yeah.
knowledge or the experience. Leave that to the people at the top. Just do what you're told and trust that it's been evaluated right. And if you ask too many questions about that, you don't become a missileer. That's pretty clear. So, like, I think all of that would go very fast. Like, with
You
it's
need a
designed
certain
to
like
go within a few minutes of the order
you need
being
a certain
issued.
Myers-Briggs testing personality to take on that role, probably, like carefully
It's
selected.
it's funny. It is carefully selected. It's funny because on the one hand, they don't want literal automatons. Like they could automate this whole thing. They could have automated it decades ago. It's not, you don't need AI. It's just turning switches, right? Like you can automate turning switches, but
Right.
they have always not done this. They've always said we need the human in there. We want a little human judgment. And in fact, at like the lowest levels, it's not even one human, it's two humans. It's always
Yeah.
two people, two-man rule. Now it's the two-person rule. Um, the no lone zone. I love the rhyming that they call it. But like it depends on the system how it works, but you need multiple people to turn a switch at the same time. And in theory, it's not possible for one person to do it. If you ask the missileers, they sometimes tell you, "Oh, I figured out a way you could do it." But like in principle, one person at that level is not supposed to have the power to do it. But yeah, anyway, they want the human factor, but they also don't want the human factor. They want
Right.
a human who's responsive, but not a human who's unpredictable and won't follow orders. So it's complicated.
So speaking to that human factors, like the example that pops to mind of like a close call with a human factor was I forget, it was a senior officer on the submarine during the Cuban Missile
Yeah.
Crisis, where
Yeah.
depth
Vasily
charges were falling all
Arkhipov.
around them. You
Yeah.
know his name,
Yeah.
and
Yeah.
maybe everybody should. But like, is that one of like the only examples where we were close and a human stepped in and prevented the dominoes from starting to fall?
Well, that's one where we definitely can say, like, if that human had not been on that submarine that day, they probably would have used a nuclear torpedo. And we don't
Right.
know what would have happened after that, but that would have been some kind of escalation. It would have been something. It's not necessarily the end of the world. Who knows? But like, yeah. And Arkhipov was not even supposed to. I mean, he was. It's not that he wasn't supposed to be on there, but he was not a normal fixture on that submarine. He happened to be there. He wasn't like he was the captain. He was this like high ranking guy who happened to be stationed there that day, a third guy who normally there would only be two guys there. Um, there are other
And the
close
other the
calls.
other two, to be clear, they were ready to launch.
Yeah, they're ready to launch. They were like the captain, and I forget the other one, maybe the I don't know, assistant captain. I don't know boats.
And as you said, this isn't like an Ohio class death boat with 90 megatons on board. This is a tactical weapon essentially,
They would have used,
which
yeah, it was
would
a tactical torpedo. So they thought they were being attacked by an American destroyers above them. The American destroyers were not attacking them. They were basically dropping like not grenades, but like small depth charges to try and tell them, "We
we
got
know
you,
you're
come to
there.
the surface." Right? "We've cornered
Right.
you, so give up. Haha, we win." And they thought they're trying to kill us. And in the situation where we're trying to be killed, that must mean war has happened or something. We are authorized to blow them out of the water. And the tool we have to do that is a low yield nuclear torpedo, which again, not they're not hitting cities, but what would the response have been if the US thought that the Soviets were starting to use tactical weapons at that moment? Would they have understood this was just one torpedo when a misunderstanding? What would that have done? Would there have been a retaliation in kind with a tactical weapon? Would that have pushed for like bombing Cuba or invading Cuba, which were definitely on the table? There were people pushing for that. That was very close to happening. And if that had happened, then what happens next, right? You could see a whole chain of things. Um, so that's the one that we know where it's something like that, where somebody is saying, "I'm going to use this nuke," and somebody says, "You're not going to use that nuke. We're done." The other
Right.
kinds of human close calls we have are more either with early warning systems that gave incorrect information, that where they basically said we're under attack, and either people figured out that this was false, or they, in the case of a Russian guy, Stanislav Petrov, they like declined to pass this on because they feared that it was false and that if they passed it upward, it would be overreacted to. Um, so we have a few of those cases on the US and the Soviet side that we know about. We have uh, cases where certainly presidents have had advisors suggest things that would be, Korea is one of them, right? But the Cuban Missile Crisis, things that would have escalated things highly and basically shot it down. Um, so we have places where it's pretty clear that the human factor is there. We also have cases where we know that the situation was more dangerous than, I think Cuban Missile Crisis is one of these, that the people at the charge of these systems understood at the time, where like the forces in the field were much more trigger happy than they were supposed to be. um, Dan Ellsberg, I mentioned earlier, he has this book, The Doomsday Machine, which is, a lot of it is about him and his work as a analyst for the Rand Corporation. He's the Pentagon Papers leaker, but this was before he did the Pentagon paper stuff. He was in charge of analyzing command and control problems in the United States, and he didn't really leak anything on that until the book is a lot of him saying, here's what I told the Kennedy administration, here's what was actually going on. He actually went to places like South Korea, to these forward bases where we had nukes, and talked to the people there about the procedures, and realized like, wow, they're doing the most dangerous thing you could imagine doing. That's really terrifying. That will, in the event of a crisis, this could lead to a nuclear explosion, and that could make people think we'd started nuclear war, and the people at the base would think that nuclear war had started, and they had no locks on the weapons at that time, and they could have just attacked. And so it's a really fascinating book. And he goes through a lot of stuff. And one of the things he says about the Cuban Missile Crisis, which I find fairly compelling, it's interesting. The standard reason why it ended is, the two fellows looked eye to eye and the other guy blinked or whatever. I think it's Atchison who said that. And we've known that that's not true for a long time. But like, why does Khrushchev push to end it when he does? He pushes really hard to end it all of a sudden. He accepts terms. It's clear that there's people in the Politburo who don't want to accept those terms. That Khrushchev just essentially pushes to end the thing really suddenly, and is willing to, like, as the kids would say today, take the L, like back down and really not succeed at this. Why does he do that at that moment? And Dan's argument, which I don't think is totally, I think is fairly plausible. I don't know what all the Cuban Missile scholars think about this. Um, but basically, the US had delivered this sort of secret ultimatum to the Soviets that said, look, if you shoot down another one of our planes in Cuba, we're going to escalate. We're going to escalate hard. So stop trying to shoot down our U-2 planes or other photography planes. Just knock it off. Because if you do that, that's a red line. We're just letting you know, huge red line, shooting down another plane. And in Cuba, the people who are trying to shoot down the planes are the Cubans,
And they're
not the
pretty trigger
Soviets.
happy.
Yeah.
Yeah.
And they're not good at it, but they're getting better. They're getting experience. They're trying every day, and they're getting a little better at trying to shoot down planes. And Khrushchev realizes he doesn't have control over that. He doesn't have control over the Cubans at all. He can't tell Castro exactly what to do. And if this goes on, they're going to get lucky and shoot down one of those planes. And the Soviets are going to be blamed for it. The US is not going to believe that the Soviets don't have control over the Cubans, and then they're going to escalate it, and it's not going to be in Khrushchev's power. So Dan is arguing that, like, he thinks that's what actually triggers the end of the crisis, is the fact that the guy in Moscow realizes that the guy in Havana is not under his control and is going to accidentally start nuclear war, and that is too much of a risk to deal with. And I think that's an interesting example, again, of this human. It's not a technical thing. It's even not a deterrence thing. It's a, like, oh man, how much control do we have over the people at the lowest level of these things? And how out of disconnect is the policy from those people's actions?
And at that time, you were saying the U.S. had a 20-1 advantage over the Russians. Getting to this question, and maybe this will be sort of our close here of, what's held us back. Mad mutually assured destruction seems to be a pretty good reason not to start lobbing nukes at each other. And again, part of the reason why you need the hardening of these systems that you were describing to be able to resist EMP pulses for whatever reason, have a credible ability to respond. But maybe just let's explore that to kind of cap off this very interesting conversation.
So the one thing I always point out, MAD is one flavor of deterrence. So there's a broader idea as deterrence, which is basically, which we don't have to get all the details. There's also a thing called compellence. Anyway, deterrence is basically me making a threat to you and saying, don't do this thing against me, or I'll do this thing against you. Right. So that's the essential nature of it. Don't nuke me, or I'm going to nuke you. Mutually assured destruction is the idea that we are safer if we're both mutually vulnerable to this kind of threat. And so it was only any kind of official policy for like a moment in the 60s, but the military didn't like it. Even the US didn't really like it because we don't really like being vulnerable. So like if you really embrace mutually assured destruction, you would not pursue missile defense because that actually breaks the dynamic if you believe in mutually assured destruction, because you sort of want to enhance the vulnerability and say like, look, we'll both be vulnerable and thus we'll never be tempted to try and go first. If you go first, you might be able to knock out some percentage of the nuclear forces or the command and control system or decapitate the leadership, and maybe you avoid getting nuked at all. In a MAD relationship, you want to make sure nobody has any temptation to go first whatsoever. We generally have never done that. We've always wanted in the United States, we keep open the possibility of going first, even though we will say we won't likely go first. We actually never say we've never done a no first use pledge. We've never said we will definitely not go first. We always say probably not, but don't try us, right? Don't think you can get anything. Don't get cute. Don't use bioweapons against us and say, oh, they're not technically nuclear weapons. Well, you don't get to go first. No, we'll nuke you. Like we use the ambiguity and hope that
Right.
keeps things deterrency. There are other ways you can think about deterrence. I think the biggest mistake people have about deterrence is thinking that it needs to be that mutual or at parity. So my favorite example of this is like North Korea. North Korea might have a dozen nuclear weapons of unknown reliability on top of missiles of unknown reliability and unknown range. Unknown doesn't mean zero. It's enough that we the United States has many more weapons that are a very much more better known reliability and accuracy and everything like that. There's no parity there, right? They don't have the ability to hurt us as much as we can hurt them. But we are pretty effectively deterred by them. We don't want to invade North Korea because the cost they could exact against us is not worth whatever we would get from destroying them, right? What do we get if we destroy North Korea and they don't hit us? We get a broken North Korea that now we have to deal with, right? Like South Korea now has to like reintegrate with this radioactive sludge. We have to figure out like what the future, we have to deal with the international fallout that would come from that. Um, and like, okay, we've reduced one threat, but we probably create other threats in the process, right? Like it's not worth it. Even if we got that, it wouldn't be worth losing Los Angeles, right? Like that's not a good trade, right? Like if I was North Korea, I'd aim at places like Los Angeles or San Jose, not because I dislike these places. I have like family who live near there, but they're like big soft targets. And or even if they don't try to hit us, we don't want to lose South Korea or Tokyo. Like they can hit stuff near them probably much easier, and so, like, none of that is worth the cost. And the example I like to also use is there's a lot of YouTube videos of house cats scaring off bears.
Right.
I don't know if you're familiar with this genre of content. And
I
of
will be
course,
soon.
yeah, like a bear could eat a house cat. Like a bear is all muscle, right? Like there's no competition. But the bear evaluation is I don't know what this little thing is. It is angry. It is full of claws. It doesn't look delicious. It's trying to scratch my eyes out. I need my eyes. This is not
Yeah.
worth it. I'm going home.
Yeah.
I'm out of here, right? And like that's another way to think about deterrence. So I always like to bring this up because if you think of it as being matched or matching tit for tat perfect thing, then you need all of these systems and all of these nukes and all this redundancy. If you think that it's about just raising the cost to something unacceptable, we could argue about what the Russians or Chinese think is unacceptable. And that's a complicated question, and people will say they don't value life as much as us. I don't know. But like you could argue about that. But if you only need a smaller number, this is what they call the minimum means of deterrence. Like, what's the minimum amount you need to make it not worth it? For years, the Chinese thought that was about 100 something, and the British think it's about 100 something, and the French think it's about 100 something, right? These are this like smaller, deliberately capped arsenals. It seems like China now thinks the number is bigger than that. They've been expanding. And they
Yeah.
probably think that because we've been threatening their minimum means of deterrence. I don't know this for, there's probably a lot of factors going on because these things always have a lot of internal factors. But like, we've been investing in missile defense. We've been investing in cyber attacks. We've been investing in very fast, accurate missiles. And 100 missiles might not be able to survive our worst attempts to blunt their deterrent. And they might worry that we would think at some future time that we're going to feel like they can't deter us. So, okay, one way to do that is to make like 3 times as many missiles and add a bunch of hypersonic warheads onto them. And now you can't, now we're still deterring you. And so, I feel like we should be pushing towards the minimum. And I get annoyed that some of our policies seem to be not only pushing us, but also like other countries like North Korea and China towards not feeling like they have that. But anyway, that's that. Sorry, long divergence. Why haven't we used nukes? I don't know. I mean, yeah, deterrence is probably part of it. I don't think it's the whole story, especially is definitely not the story for the early nuclear period where those dynamics had not been set up and the theory had not completely taken hold. Like the US did not believe in nuclear deterrence in the 40s and much of the 50s. It believed in first strikes. It believed in nuclear threats of disproportionate retaliation even against non-nuclear attacks. Like that's not deterrence. But I think it's one of the things that's so just to go all the way back to Truman. The Why didn't Truman use nuclear weapons in the Korean War? Like there were rational arguments against using them. My favorite is they probably would not lead to an instant resolution of the war, and that would devalue this bomb, right? Imagine you use this nuke against 5 Chinese airfields and the Chinese don't pack up and instead they redouble their attack. What have you done to this thing that you still are the only nation that has this threat in your pocket? It's better to keep it as a threat. And also, what if you normalize using it? We are way more vulnerable in our military endeavors. This is one of the arguments against using it in Vietnam. You probably wouldn't win. And if you normalize the use of nuclear weapons, combat level nuclear weapons, American bases are way more vulnerable. We're centralized. We put everything on one big base. The guerrillas don't do that, right? Like so, like there's like we don't want to normalize. We benefit from the what they call the nuclear taboo or nuclear non-use. Um, but why didn't we use it in Korea? Because Harry Truman didn't want to use it. Like if you had put different people in that role, I think if Eisenhower had been president in 50, they probably would have used nuclear weapons in Korea tactically.
Wow.
Like he was not opposed to that at that point. Um, so I think it's interesting to look at that again, the personal factor. It's why I think writing a book on Truman is valuable. Is it's as historians, we try to look at forces and big things and the markets and the economies and culture and the sort and often devalue individuals because we're not doing great man history anymore, which is correct. But there are sometimes people in positions of great influence. And I'm not saying he's a great man or anything like this, but some of this came down to like idiosyncratic, individual, psychological, that guy on that day. And one of the things that's kind of terrifying about nuclear weapons, even today, is that because the use questions are so centralized, you're really talking about how a small number of people feel about them on any given day or any given crisis. Like it's
Right.
not the forces that will determine whether so with like Ukraine, it's not global forces that will determine whether or not Russia uses nuclear weapon. It's Vladimir Putin. Like how much what's going on inside that head? I don't know. And I don't know. I'm not saying there's one reaction to that, but like that's unusual to centralize that kind of power, even in a state like that, to have it be that decision be that centralized. nuclear weapons do that in a way that almost nothing else does.
Okay, so I think this will be the concluding question. But you mentioned you're working on another kind of web based tool. You have
Yeah.
Nuke Map, and it has to do with threats of apocalypse. By way of kind of closing out and shining a light on that project, nuclear winter is something that's at least is top of my mind in terms of thinking about. That's what I was sort of mischaracterizing as mutually assured destruction, but.
Oh yeah, sure.
Um, how kind of valid is that as a term, or how much is it a deterrent? I mean, I think obviously that would be different in terms of something more limited, smaller arsenals like North Korea or Israel or something like that. But in terms of the Russians and Americans or Chinese and Americans lobbing stuff back and forth, what does that look like in kind of a worst case apocalyptic scenario? And does your web based tool touch on that?
Or even the other one that has been studied for that is India, Pakistan. So that's a fair amount of nuking. So, 100 on each side, more or less. What is the impact of that? The answer is it's hard to know. I, you know, the these are very so the work on whether nuclear winter, just to make sure everybody's on the same page, it's caused by burning. So it's not the mushroom cloud, it's not radioactivity, it's how much stuff do you set on fire? And then do those fires send up particulate matter like soot into the upper atmosphere? And if you burn enough fires all at once, does that create sort of a layer that is reflecting some amount of sunlight? So kind of like some of these geoengineering ideas. The other thing it's kind of like are when these massive volcanoes erupt, and those can put up the Tambora eruption in 1815 put up enough stuff in the air that crops failed in Europe for several years. It was the year without a summer, way far. Tambora is in Indonesia. This affected Europe, and they basically the sun didn't come out for a summer. And interestingly, just to plug the other project, the Doomsday Machines, this is where the first post-apocalyptic literature in English comes from. Is
Okay.
imagining what the world would be like if the sun just went away, and it's also where Frankenstein comes from. Anyway, it's a very interesting moment where this natural event has this rippling effect on culture because it has this rippling effect on the ecosystem. And so the idea with nuclear winter is you'd cause enough darkening for enough period of time that it would have massive impacts on food production. And so globally, you get famines as a result of this until the normal atmospheric process, essentially what they call scavenge, like raining out all this crap in the upper atmosphere. And this idea was first put out there in 1983 by a team who the most famous member of was Carl Sagan. Um, and it was immediately controversial because it's got big political implications in the sense that they're saying you can't win a nuclear war above a certain size. Like it's just literally suicidal. Um, and not only do you not win a nuclear war, but non-combatants definitely don't win it. So you could imagine a nuclear war that happens, and South America is not hit by it, and Africa is not hit by it, and maybe you know Asia, Europe, and North America are pretty heavily targeted. But that would still be bad, like, for people in South America, it's not like they'd be isolated, but you could imagine them being less invested in those outcomes than, the countries that are actually targeted. With nuclear winter, everybody is killed, essentially, and potentially you get extinction level depending on how much it is, et cetera, et cetera. Uh, the difficulty is that these equations and models are, like, pretty complicated. So you not only have to know how many nuclear what is the nuclear burning going to look like, which requires you to know the nuclear targeting. Not all targeting is the same amount of burning, right? Cities are different than deserts or water, for example, right? Um, you need to know how hot that burning is going to be and whether or not these fires are going to inject how much material and at what levels of the atmosphere. You have to know how those are going to circulate in those levels of the upper atmosphere, how much sunlight reflectivity there will be, how much the scavenging processes will be, and you're doing this on a global scale. So interestingly, some of this nuclear winter early work led to simulations that made it easier to simulate climate change because they're the same kind of general models. And there were people in the 80s who said, "Well, I ran this with my own numbers and I didn't see any wintering effects." or you see a tiny effect but none effect. And there have been people since then who have said that. There's like a guy at Los Alamos who still publishes on this, and he says, no, if you use the right input variables in physical processes, you don't get any nuclear winter effects. There have been other work by academics who have said we've refined our model and we actually find, or we've done some experimentation to get some info from these models, and we've narrowed down the amount of uncertainty, and we still see big effects. Maybe not the exact same effects as the 80s, but we still see effects that could lead to, if not, we're not necessarily extinction, but could lead to like hundreds of millions or billions of starvation deaths, because if you fail a crop at this right moment, then this could happen and things. I'm not a climate scientist at all or a modeler. I don't weigh in on this. I'm out of over my head. But for me, what's interesting is that whatever your inputs are determines your outputs. And it's not clear what the right inputs are. So there's a lot of, I don't want to say subjectivity, but people unsurprisingly tend to find the answer that matches up really well with their prior convictions. So like the military and Los Alamos tends to find that there isn't nuclear winter, and people who are against nuclear weapons tend to find that there are nuclear winter. And that doesn't mean that either of them are wrong, but it means that it's hard to know. It's hard for me, as somebody who is not an expert and does not pretend to be in this area, to possibly sort out the political categories from the technical categories, because they are a one-to-one matchup in all cases. Given that, what should the response to the uncertainty be? And this is a nice general question. Should you assume that because you can't know if nuclear winter is real, we should not factor that in to any planning? Or should you assume that because we do not know it is real and it could be real, we should assume the worst and factor it in? And what I find interesting is that also maps on to your political categories generally as well. The same people who, when you're talking about Chinese capabilities, will tell you you have to assume the worst every time, or else you're stupid and suicidal, right? If you don't assume the Russians and the Chinese are waiting every minute of the day for us to make one mistake and then they can nuke us all, which I think is highly unlikely to be. I don't see any
Right.
evidence of that. But like that's the common military assumption about this. They assume the worst case in the face of that uncertainty. But when it comes to something that threatens their nuclear plans, they suddenly say, like, hey, if there's no evidence for it, don't worry about it. I think that's an interesting the politics of uncertainty to me is the interesting part. But I would say for any of your listeners, if you're used to seeing people say, oh, I heard they disproved nuclear winter, that's not true. But also, it's not true that they proved it. Like, it's
Right.
in this
Right.
limbo. There are active researchers doing, I've worked with some of them, not in the research side, but with some of the logistics. I'm building some software to help them with their data management stuff. Uh, uh, like, who do research on this, and I don't think they're uh, nobody's a bad scientist, but they are still human beings, and the same can be true of the Los Alamos people, who I don't know. I don't think any of them are probably evil, but I do think that they have in the face of this thing where it's not clear what the right answer is or how, and we're never going to be able to test it really unless we get into a really bad situation. uh like, how do we deal with this uncertainty, and what should the response be? I think that's the interesting social question.
At least it's low stakes, so
Yeah, right,
Um,
like, it doesn't matter. Yeah, it's a
all
fun
right, so
trolley problem.
well,
Yeah.
let's just close. I want you to because I'm personally interested, and the website's going to go live soon. So it was the Doomsday Machine. Is that what it was called?
Doomsday Machines, plural.
Machines, plural. Okay, so just tell us a little bit more about that because I'm intrigued.
So Doomsday Machines is I'm calling it an exploration of the post-apocalyptic imagination in fact and fiction, though you could argue that it's all fiction to some degree. But so part of it is going to be, the backstory is I've been working on a video game for the last few years with students, which I've never made a video game before. I've been programming a long time, but that's been a very interesting exploration and thinking about game design and world building and fiction, which is also not really what I do. And it's a video game that is set in 1983 after a full-scale nuclear war. It's basically Oregon Trail in that place and that setting. And I'm trying to make it a very plausible world. Like, I'm trying to actually look into like modeling what that would really look like as part of the port of the game. And so as I've been working on that, I've been going through all these historical documents that are like US government models for what the post nuclear situation might look like, which range in what they even look at and gets you into wonderfully deep, like micro questions like how much gasoline would there be, right? Like that's a fascinating, and for a game where you have to use a car, like that's a key. I want a realistic gasoline
Wow.
availability model along with the
Yeah.
radiation models and the fallout and all this kind of stuff. It's got like realistic fallout models, et cetera, realistic targeting. So it's pulling together a lot of stuff I'm interested in as a historian, but also this kind of world building stuff. But in the process, I'm also looking for ideas for the fictional content of it. So I've been reading even more post apocalyptic fiction than usual and watching more movies and thinking about it this way. And I had this thought of like, man, I should do something with all this. This is fun. And also can be a dev blog for the game, which, build up a little bit of interest and knowledge about it. So basically, what this is part of it is discussions of fiction, self-conscious fiction. So one of the first posts will be about The Road, which I've thought a lot about. Cormac McCarthy's The Road, and is sort of things that I thought were interesting about The Road, and things I thought other people would find interesting about The Road. Like what Cormac McCarthy thought the book was about is probably not what you think it's about, and that's interesting. And also, it was like chosen by Oprah to be her book club book. What is going on with that? How should we think about this? Anyway, in 2006 or whatever, what does this tell us? So it's kind of like a little media analysis, but with a strong historical bent to it and some trope analysis. One part of it is going over these official government document stuff, like interesting stuff that's come up that I've learned about from there, or weird documents that I found that I think other people would find interesting or illustrate some way in which governments plan nuclear war or plan recovering from it. Part of it is about the game and world building. So it's some of it's just going to be about like why I decided we needed to have faces for everybody you talk to in the game, and how we set up a system to do faces in this weird retro 90s inspired game thing that we've been building with a bunch of undergraduates for several years. And that's fun if you're interested in game design, but it's also about fiction and like why I need a face. Like I hate games where I don't get to see who I'm talking to. I just can't get into it. Even if it's a dumb little animated thing, I like a face. It's also going to have stuff on like how we built up the radiation model and how we built up the food available model, stuff that powers the game, but might not, the research might not be obvious to anybody playing it. And I think it might be fun. And then some of it's just, I'm going to be interviewing people kind of like what you're doing here, who I've known over the years who work on various aspects of the end of the world. It might be nuclear winter people. It might be anthropologists who study preppers. It might be, I have friends who do all sorts of weird historical and technical stuff over the years. So I'm going to interview these people. So that's basically what it's going to be, plus some miscellaneous fun things that I found over time. So I think it'll be fun. It's for the kind of person who, if any of those things sounded interesting to you, you should go there because it's going to be like it's going to be fun and it's going to be different. It's not the same old stuff. It's a weird little mixture of stuff, and everything's kind of short. And I think it's gonna be really fun. So I'm very jazzed about it.
I'm one of those people that has a hard time with kind of suspension of disbelief, and when I'm watching a show and I see something that just is not realistic, it completely falls off for me. So I think I'll be a super fan here because it sounds like you're doing a lot of rigorous analysis to make it hyper real. Okay, we went 45 minutes over. Happy to do
That's
so.
fine.
Thanks so much for being so generous with your time, and
Of
as
course.
always, like so much nuance here. Again, did a bunch of prep for this and just learned so much more. So thanks again, and hope to talk to you again soon.
Yeah, I'll be ready for part three. Anyway, good to talk with you. Super fun.